Good afternoon, everyone, and welcome to the second lecture on CAD tools. Today, we will explore the historical developments of machine translation from automatic translation to the cloud platforms we use every day. We will see how machine translation and computer-assisted translation evolved separately, then converged into the workflows that shape our profession. By the end of this lesson, you will have a clear timeline about the history of both. You will get to know the key turning points and reach an understanding of what they mean for translators, clients, and translation education. So this lecture begins by looking at the early ideas and concepts that appeared before 1949. Then we will follow the development of machine translation through different historical stages. So we'll start with the 1950s, which is the early period of machine translation. And then we move to its institutional growth in the 1960s, the diversification of machine translation tools, and the emergence of computer-aided translation tools in the 1970s, the start of the commercial use of machine translation in the 1980s and 1990s, and finally, the rise of statistical and neural machine translation. In the following step, we'll examine how computer-aided translation tools were created and developed, and end by looking at how machine translation and computer-aided translation are now combined in modern cloud-based translation environments. So the history of machine translation goes back to the era before 1949, at which some conceptual and mechanical translation ideas emerged before digital computers existed. Inventors such as George R. Stroni and Peter Tujansky created mechanical translation machines and registered their patents in the early 1930s. Later, during the Second World War, Alan Turing works on computation and cryptography provided the theoretical foundation for using machines to process language. These early efforts show that the idea of machine translation came before the invention of digital computers. Well, despite these early efforts, the story of machine translation truly began in 1949 when Warren Weaver, an American scientist, published a visionary memorandum in which he proposed that computers could translate languages much like they deciphered secret codes during the Second World War. The ideas of Weaver seeded research across Europe and the United States and inspired many linguists, mathematicians, and computer scientists to collaborate on this new path. Another important event that marked the history of machine translation is the first demonstration of an automatic translator by IBM and Georgetown University in 1954. So the IBM company and the Georgetown University research group designed a prototype which translated 49 Russian sentences into English using a vocabulary of 250 words and some rules. Despite their prototype was limited, it captured the global attention and set off a wave of enthusiasm and high expectations for rapid progress. Following the IBM Georgetown demonstration in 1954, many governments and universities started machine translation programs in the 1950s and the 1960s. At the Massachusetts Institute of Technology, Yoshua Bar Hillel became the first MT researcher. Some projects also appeared in the USSR, Canada, and Japan. However, at that time, linguistic theories were not yet advanced and computers were still weak, which made it difficult to build strong machine translation systems. In 1966, the report published by the Automatic Language Processing Advisory Committee, ALPAC, marked a major turning point for machine translation. The report concluded that machine translation systems were slower, less accurate, and more expensive than human translators. As a result, US funding for machine translation research was drastically reduced and many projects were stopped. Despite this setback, the period led to important advances, such as controlled languages, sub-languages, and pre-post editing techniques, which paved the way for more practical machine translation applications. One key example is the Meteo system developed in Canada in 1977, which automatically translated daily weather forecasts from English into French for public distribution. Despite the United States cut its funding, machine translation continued to develop in other countries. The 1970s was the era of diversification and international growth. Many translation systems were developed during this period, including Systron, which was founded in 1968, Logos in 1969, and Eurotra, which started in Europe in the same year. In Canada, the Meteo system, launched in 1977, successfully translated weather reports using a rule-based transfer method. This showed that focusing on a specific domain can lead to high-quality machine translation results. In the 1980s, the arrival of personal computers made machine translation more accessible to translators and organizations. Around the same time, Martin Kay introduced the idea of the translator's workstation, a computer-based environment designed to support translators in their work rather than replace them. This concept later developed into CAT-tools, which focused on helping translators work faster and more accurately. Early computer-aided translation systems included translation memories, terminology databases, and concordances, all aimed at boosting productivity and consistency in translation. In the 1990s, CAT tools such as Trados, DejaVu, and Multitrans became available as commercial products. At the same time, researchers at IBM developed statistical machine translation, which used large amounts of data instead of handwritten rules. In 1997, the launch of Alta Vista's Babelfish made machine translation available on the web for the first time. This turned automatic translation into a public service and also provided more digital bilingual texts, which were later used to train data-driven machine translation systems. From the mid-1990s, statistical machine translation began to replace rule-based methods. Instead of relying on manually written rules, statistical machine translation used probability models trained on parallel corpora. These are large collections of text with their translations. Toolkits like Moses made it easy to build statistical machine translation systems for many languages. For about 2 decades, statistical machine translation dominated both research and industry, powering well-known systems like Google Translate and Bing Translator. However, its translations were often fragmented and very literal, lacking natural fluency. Around 2014 appeared neural machine translation. This approach to machine translation uses deep learning to translate whole sentences at once instead of breaking them into small parts. Neural machine translation produced translations that were more fluent and cohesive and could handle word forms and grammar better than previous methods. Neural machine translation became the new standard. However, because neural machine translation output often sounds smooth and natural, it can hide small but important errors, which makes professional post-editing and careful evaluation more important than ever. Now, if we want to summarize the development of machine translation from its early days to the 1970s, we can say that before 1949, machine translation existed mainly as a theoretical idea shaped by developments in logic, cryptography, and early computing. In 1949, Warren Weaver's memorandum laid the theoretical foundation for machine translation, proposing the use of information theory to decode languages. This inspired the first public machine translation demonstration in 1954 through the Georgetown IBM experiment, which generated great optimism about the future of automated translation. The following years saw institutional expansion as universities and governments, particularly during the Cold War, invested heavily in machine translation research programs. By the 1970s, machine translation had diversified internationally, with new research centers emerging in Europe and Asia, making the transition from localized experimentation to a globally collaborative field. Now, if we want to talk about the development of machine translation approaches from the 1950s to the present, we could say that they started with rule-based machine translation approach, which appeared in the 1950s and lasted until the 1970s. This approach depended on linguistic rules. It was followed during the 60s and the 70s by the interlingua approach or the interlingua approaches, which introduced an intermediary language to translate between languages in order to improve accuracy. The 1980s saw the rise of knowledge-based machine translation, and it was quickly replaced by the example-based machine translation approach in the 1990s. Example-based machine translation is a corpus-based machine translation, which was based on reusing previous translations. From the mid-1990s to the 2010s, the statistical method or the statistical machine translation approach was dominant, and it relied on large bilingual corpora and probabilities. A major event, a major development in the history of machine translation approaches arrived in 2014 with the advent of neural machine translation approach. This approach uses deep learning to produce more natural translation. Finally, from 2018 to the present, AI-based machine translation approach has taken over. This approach integrates advanced artificial intelligence to make translations smarter and more adaptable. Now we move to the development of CAT tools, and we can start by the 1970s with the introduction of translation memories. And we can say that machine translation was making technological progress, and CAT tools were becoming stronger commercially during the 1980s and the 1990s. Translator workstations became standard tools in many translation agencies and large organizations, and by the 2000, CAT tools began to connect to online resources such as web dictionaries, stamp banks, and parallel corpora, which increased translators' independence and speed. Then, with the growth of the broadband internet and cloud platforms, translators started to work together online. Shared translation memories, terminology databases, and centralized project management became common practices. CAT tools moved to the cloud, allowing distributed teams to collaborate smoothly across different time zones. Over the past 2 decades, machine translation and computer-assisted translation have become increasingly integrated. Modern CAT tools such as Trados, WordFast, MateCat, and others now include machine translation engines directly, so translators can see machine-generated proposals next to the translation memory matches. They can accept, reject, or edit these suggestions, which makes post-editing a standard part of the translation workflow across the industry. The arrival of large language models has transformed how machine translation works inside CAT tools. In the past, machine translation systems offered only one best guess translation. Today, they can use extra information such as translation memories, term bases, and previous segments to generate better translation proposals. A method called retrieval augmented generation allows the system to bring in trusted information during translation, which reduces errors and helps make the output match the client's style and feel more closely. For translators, this means fewer basic mistakes, but they must still stay alert, a sentence might sound fluent but carry the wrong meaning. They also need to follow confidentiality rules when using online tools or storing data in secure environments. Now, as this timeline shows, computer-assisted translation tools have developed over time, starting from the 1970s, when the concept of translation memory was introduced. This concept laid the foundation for modern computer-assisted translation technology. During the 1980s, the idea of a translator's workstation was proposed, envisioning tools that would support translators throughout the translation process. In the 1990s, CAT tools became commercial products, making them more widely available. By the 2000s, they were adopted by agencies and large organizations and became essential in professional translation workflows. The 2010s saw the rise of online resources and cloud-based workflows, which improved collaboration and accessibility. More recently, CAT tools have started integrating machine translation engines for post-editing, and today large language models are being embedded in CAT tools environments, making a new era of intelligent translation assistants. In recent years, generative AI has begun to support translators at every stage of their work. It can clean and prepare source text, provide guided pre-translations, rewrite sentences to match a desired style, explain its proposals, and offer quick quality tips during translation. These systems can learn the client's tone, level of formality, and preferred style. They can also automatically correct punctuation, capitalization, numbers, and tags, which helps maintain consistency throughout the translation. However, using this technology professionally requires clear rules. Organizations must protect data, prevent unwanted model training, ensure that results can be reproduced, and keep detailed records of the system's actions. Because generative AI is slower and more costly than regular neural machine translation, translation teams often combine both. They use neural machine translation for fast, simple segments and generative AI for more complex parts, where style, context, or word knowledge play a bigger role. Post-Translation Management System, or TMS, platforms mark a new stage in translation technology. Unlike traditional TMS, which focused mainly on workflow management, post-translation management systems bring together CAT tools, machine translation, generative AI, and statistics in one cloud-based environment. This integration supports a more collaborative and efficient translation process, allowing teams to work in real time across different content types such as text, audio, or software strings. This evolution has encouraged the rise of augmented translation, where the human translator remains at the center while AI provides context and support. By using wider contextual memory such as paragraphs, customer service messages, release notes, or knowledge graphs, these systems ensure more accurate terminology and relationships in translation proposals. Their effectiveness depends on solid evaluation methods, secure data handling, and structured feedback that improves AI models without exposing client information. To conclude, we can say that machine translation has evolved from early mechanical systems to neural models with fluent output and now to large language models-based augmentation. Over time, machine translation and CAT tools have become closely linked, with the human translators remaining at the center of the process. Translators now play a crucial role in providing context, using correct terminology, ensuring the intended meaning, and choosing the right tool for each task. Using fast neural machine translation for simple segments and flexible generative AI for more complex ones. Organizations that manage their data carefully through clean translation memories, controlled term bases, knowledge graphs, and secure systems can achieve the best results. Looking at the future, the real progress will depend not only on speed, but also on evaluation and ethics. This includes quality checks that assess risk, protecting client privacy, and building systems that keep improving safely without exposing sensitive information. This lecture is based on a selection of recent works that examine the development of machine translation and CAD tools. These include De Palma and Lommel 2025 on AI's impact on translation, Gaspari 2024 on the history of translation technologies, Al-Mahassis 2022 on English-Arabic machine translation evaluation, and Sinway 2004 on translation technology terminology. As a closing note, we can say that as future translators and language professionals, it is essential for you to understand translation technologies, develop strong practical skills, and maintain a critical mindset when working with machine translation and generative AI. Rather than replacing you, these tools will reshape your role, place you at the heart of a dynamic and technology-driven translation process. Any questions related to this lecture should be addressed during the face-to-face session or posted on the Moodle platform for further discussion. Thank you for your attention and active participation.